Hey, what's going on, guys? Let's do this problem right here. The question is asking how much work is required to compress 7.5 moles of an ideal gas at 400 Kelvin from 5.2 liter to 2.1 liter. And that's our first question. And second question is asking for the change in internal energy, and the third is asking for the heat transfer, right? So let's begin with the first one. Uh, but before we go for that, if you notice, this is the temperature right here. It's constant, so it means this is an isothermal process. Isothermal process, and in an isothermal process, delta U is equal to 0, right? So this answers the second question. The second question is asking what is the change in internal energy? That is 0. And also, if you want to clarify this one a little bit more, you can use this equation. Delta U is equal to NCV delta T. Since the initial and final temperature are same, when you subtract them, you will get 0. So when you multiply 0 with everything, you will get 0. So that's how we can derive this one. And we have answered the B part already, right? So let's say this is B part, and we have answered this one already. And the first question is asking how much work is required. So that's our first question. So let's see how we can calculate. So let's draw the pressure and volume graph. So here we have pressure and here we have volume. And you know that when the pressure decreases, when the volume increases, the pressure decreases, right? According to Boyle's law, it's not going to decrease like directly like this. It's going to decrease like this, right? So we are interested in this area right here. That's going to give us the work. So we can't use like any rectangle equation or anything to find this area. Here we have to use the calculus. So if you know the calculus, we can use work to find the work. We can use integral A to B pressure in terms of dV, right? And this equation we can use to find the work. So let's see how we can do this. And A to B is, since we are talking about dV, A to B is going to be the volume change. So initial, final, so 5.2 to 2.1. So that's going to be the limits of integration. And let's put P in terms of this one. We know that PV is equal to nRT. Therefore, P is going to be equal to nRT divided by V. So we can substitute this one instead of this because we have the mole, we know the R, and we know the temperature. So we can only use this one to find this. We don't know the pressure directly, right? So we can substitute this value to find this one. So let's rewrite this one in terms of that. So this is going to be A, B, and pressure is going to be nRT divided by V dV. And if you notice, this is, we are writing dV. So dV means everything except V is going to be a constant. So we can move this nRT to the front. This is going to be a constant. So let's leave 1 over V right here and move nRT to the front. So this is going to be nRT integral A to B 1 over V dV. If you have taken the calculus, you know that 1 over V is integral of 1 over V is ln V. So we can integrate directly, right? So this is going to give us ln V. So let's do the integration. So this is going to be equal to nRT ln of V, and that's going from A to B. So here A and B is going to be the initial volume and the final volume, right? So that's what we have, and let's separate them. So this is going to be what? nRT ln of B, that's going to be final volume, minus nRT ln of A, that's going to be the initial volume. And according to logarithm, when we subtract, that's going to be same as this one, nRT ln B over A. It's same thing as subtracting. When we add, we multiply. when we subtract we divide. So that's the rule we are going to use. And let's plug all the values. We have the mole that's provided 7.5 moles, so let's plug the 7.5 moles right here, multiply by R, that's going to be 8.3145, multiply by the temperature, that's 400 Kelvin, 400 multiply by ln B over A. So B is here the final volume, that's 2.1, divided by initial volume, that's 5.2, and if you plug all the values in the calculator, you will get negative 22614 joule. So we expect the answer in negative because if you see the question, they are saying it's compressed. So whenever work done to the system, it's going to be negative. So whenever we have done by the system, it's going to be positive. If they say this expands, we have to have a positive answer. Since they are saying it's compressed, it means work done to the system. So the answer is of course negative. So this is the A part. And B part, as we discussed already, we solved it like for an isothermal process, delta G is always 0 because the delta T is going to be 0. That changes everything, that make everything 0, right? That's part B. So let's see how we can calculate the part C. So the part C is asking how much heat will be transferred during this process. If you remember that we can use this equation to find the heat, that's Q is equal to delta U plus W, and we have already found that delta U is equal to 0. So this one is going to be equal to 0. So therefore Q is going to be equal to W, right? So Q is going to be equal to W. Therefore Q is equal to negative 22614 joule. And that is the answer for the C part. I hope you guys found this video helpful. Thanks for watching.